Okay, last part. What we can do is we can extend this into 3 dimensions. So cuboid B is an enlargement of cuboid A. That can be equally true in 3 dimensions. The scale factor is 2. So let's look at what the volume of the 2 cuboids are. So volume of A is going to be 3 times 4 times 5, which is, I think, 120. 3 times 4 times 5, 60. Okay, the volume of B, well, if the scale factor is 2, then that's going to be 10, that's going to be 8, that's going to be 6. So it will be 6 times 8 times 10. 6 times 8 times 10 equals 480. Okay? Now, the length scale factor is equal to 2. But you will notice that the volume scale factor is not equal to 2. It's 480 divided by 60, which is 8. And that is because the volume scale factor is actually the cube of the length scale factor. So area was squared, volume is cubed. It's all logical, just makes sense. Okay? If you're talking about surface area, well, that's an area. So if we want the area scale factor, well, that's going to be 4, 2 squared. So the question is asking you about surface area, you need to use the area scale factor. The question is asking you about volume, you need to use the volume scale factor. Okay, let's just delete this. Let's look at the second part of the question. Here are 2 similar prisms. The volume of C is 10 and the volume of D is 270. Work out X. Okay, so what we need to do first of all is we know the volume scale factor is 270 divided by 10, which is 27. That means the length scale factor, we're working backwards here. So if I can find the volume scale factor by cubing, I can find the length factor by cube rooting. Okay, the cube root of 27 is 3. We're going to do the cubed root. Okay. So now I've got the right scale factor. X times 3. So small times the scale factor equals big. So X equals 12 over 3. X equals to 4. Okay. Now it says, given that the surface area of D is 693, work out the surface area of C. So what I need to know is the area scale factor. Well, it's the length scale factor squared. Okay, so D has 693, so C's surface area, okay, times the scale factor 9 is equal to 693. So C's surface area is 693 over 9. Use my calculator. 693 divided by 9 equals 77 centimetres squared. Okay? So just summarise all of that. Let's just get rid of that. If the length scale factor is x, then the area scale factor is x squared, and the volume scale factor is x cubed. Okay? That's the relationship between all of them. Just make sure that you're using the right scale factor for what you're actually trying to work out. Okay? So here we go. We've got cylinders A and B are similar with heights of 2 and 4 respectively. Cylinder A has a volume of 10. Find the volume of cylinder B. Very easy. The length scale factor is equal to 2. 4 divided by 2. So the volume scale factor is equal to 2 cubed, which is 8. So all I need to do is to find the volume of B is simply going to be the volume of A, which is 10, times the correct scale factor, 80 centimetres cubed. Very straightforward. A and B are similar cones with volumes of 54 and 250 respectively. Okay, let's draw that. Here is a cone, and let's call that one A, and then we've got cone B with a larger volume. Okay, and we appear to know that the height of cone A is 6, and we know the volume is 54 centimetres cubed and 250 centimetres cubed. What I know here, what we want to know is the height of B, so let's call this X. We know the volume scale factor is 250 divided by 54. Let's use a calculator. 250 divided by 54, which equals 125 over 27. So the length scale factor is the cubed root of 125 over 27, which is actually 5 over 3. Cube root of 125 is 5, cube root of 27 is 3. Let's just leave it like that. So that's the length scale factor. So if I want to know X, well, that's the large one. So 6 times the scale factor is equal to the large, small times scale factor equals large. So X is going to be equal to 30 over 3. X is equal to 10 centimetres. The height of cone B is 10 centimetres. Okay, that's it. Okay, so we've got some My iMaths and a Microsoft form to be able to practice these concepts. Okay, let me know if you've got